11.3 is on combinations. So imagine that you ask your friends the following question. Consider the 6 founding members of the Avengers: Captain America, Iron Man, Thor, the Hulk, Black Widow, and Hawkeye. Of these 6 people, which 3 would you select to be included in a documentary featuring their individual stories? You are not asking your friends to rank their 3 favorite Avengers in any kind of order. They should merely select the 3 to be included in the documentary. One friend answers Iron Man, Thor, and Black Widow. Another responds Black Widow, Thor, and Iron Man. These 2 people have the same Avengers in their group of selections, even if they are named in a different order. We are interested in which Avengers are named, not the order in which they are named. Now, because the items are taken without regard to order, this is not a permutation problem. No ranking of any sort is involved. So later on, you ask your roommate which 3 Avengers she would select for the documentary, and she names Hawkeye, Black Widow, and Captain America. So because her selection is different from those of your other 2 friends, then different Avengers are cited. So mathematicians describe the group of Avengers given by your roommate as a combination. A combination of items occurs when the items are selected from the same group, no item is used more than once, and the order of the items makes no difference. So for each of the following problems, determine whether one is involving permutations or combinations. We're not trying to solve them. We just want to know, is it a permutation or a combination? So 6 students are running for student government president, vice president, and treasurer. The student with the greatest number of votes becomes the president. The second highest vote getter becomes vice president, and the student who gets the third largest number of votes will be treasurer. How many different outcomes are possible for these 3 positions? So because the order of the officers makes a difference between president, vice president, and treasurer, then this is a permutation. Six people are on a board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed from the 6 people? And so there is not any different roles going on here. It's just 3 people that are going to be on a committee. And so because order does not matter, this is a combination. And Baskin-Robbins offers 31 different flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? So the order in which the scoops are put into the bowl doesn't matter. It's just based on those 3 flavors. And so because order does not matter, this is also a combination. So we've already saw the notation for a permutation, but we have something really similar for a combination. So instead of NPR, we have NCR. So let's consider the letters of A, B, C, and D. The number of permutations for these 4 letters, taken 3 at a time, is 24 permutations. And so you can see all 24 permutations below. Now, because the order of items makes no difference in determining combinations, each column of 6 permutation represents one combination, which is ABC, ABD, ACD, and BCD. So in general, there are R factorial times as many permutations of n things taken R at a time as there are combinations of n things taken R at a time. So our formula for combinations is n factorial over n minus r factorial times r factorial. So it's very similar to the permutation one, but we just add on that r factorial on the bottom. So a 3-person committee is needed to study ways of improving public transportation. How many committees could be formed from the 8 people on the Board of Supervisors? So because we have a big group of 8, n is 8, and we need 3 people, so r would be 3. And so we have 8C3, and that's 8 factorial over 8 minus 3 factorial times 3 factorial. Well, that's r factorial over 5 factorial and 3 factorial. So we have 8 times 7 times 6 times 5 factorial all over 5 factorial times 3 times 2 times 1. And so the 5 factorials will cancel. And we have 3 times 2 on the bottom, which would give me the 6 on the top. And so now what I'm left over with is 8 times 7 over 1, which is 56 ways. In poker, a person is dealt 5 cards from a standard 52 card deck. The order in which the 5 cards are received does not matter. How many different 5-card poker hands are possible? So my big deck is 52 cards. And I only receive 5 cards. So we have 52 C5. But that's 52 factorial over 52 minus 5 factorial times 5 factorial, or 52 factorial over 47 factorial times 5 factorial. And so on top we have 52 times 51 times 50 times 49 times 48 times 47 factorial over 47 factorial times 5 times 4 times 3 times 2 times 1. So we have 47 factorial on top and bottom. And so what we have left over is 52 times 51 times 50 times 49 times 48 all over 5 times 4 times 3 times 2 times 1. And that ends up just becoming 2,598,960 ways, or poker hands, that could be dealt. So if you are a card player, it does not get any better than to be dealt a royal flush. It consists of an ace, a king, a queen, a jack, and a 10, all of the same suit, which could be hearts, diamonds, clubs, or spades. The probability of being dealt a royal flush excuse me, involves calculating the number of ways of being dealt such a hand. Just 4 of all 2,598,960 possible hands. In January 2017, the U.S. Senate consisted of 46 Democrats, 52 Republicans, and 2 independents. How many distinct 5-person committees can be formed if each committee must have 2 Democrats and 3 Republicans? So let's look at the Democrats first. So we have a big pool of 46 Democrats, and we need to have 2 Democrats that are picked. So we have 46 C2, and that's 46 factorial over 46 minus 2 factorial times 2 factorial, or 46 factorial over 44 factorial times 2 factorial, and that's 46 times 45 times 44 factorial all over 44 factorial times 2 times 1. And so the 44 factorial cancels. And we have 46 times 45 all over 2 times 1, which is just 2. And so we end up with 1,035 different ways we can pick Democrats. Now we need to consider the Republicans. We had a big pool of 52 Republicans, and we need to have 3 of them chosen. So that's 52, choose 3. And so we got 52 factorial all over 52 minus 3 factorial times 3 factorial. And that's 52 factorial all over 49 factorial times 3 factorial. So we have 52 times 51 times 50 times 49 factorial all over 49 factorial times 3 times 2 times 1. And so we can cancel 49 factorial, and we're left with 52 times 51 times 50 all over 3 times 2 times 1, which is 6. And so we get 22,100 ways to pick a Republican. And so by that principal counting theorem, because I can only be Republican or Democrat, I just want to multiply these 2 ways together. So 1,035 times 22,100 equals 22,873,500 ways of picking our committee.